So number 5 states that based on the family of the graph belongs to, which equation could represent the graph? And then I see this graph here. Okay, so let's look at this graph here and say, and let's redraw this graph. So it's 1, 2, 3. So this here I have something like this. And this here is between 3 and 4. So I'm going to say this is between 3 and 4. And then the x-axis is, and then I have something that it's at kind of like, this is -1, -2, so it's between -2 and 3, right? So maybe something like this. So 1, so between -2 and -3. Okay. So based on the family the graph belongs to, which equation can represent this graph here? So as you can see, if you look at this graph here, it looks very, very similar to a reciprocal function. This here looks very oddly similar to a reciprocal function. Because a reciprocal function, if you recall, y equals 1 over x, has something like this, right? Like, it looks very, very similar. It's just maybe translated or stretched or horizontally stretched or vertically stretched and compressed, right? So it looks very, very much so like a reciprocal function. So let me look at the options here. So we have option A, which is y equals log x plus 3. So in this case, if we graph log x plus 3, you're going to get a function that like basically steadily increases over time. So let me show you what that means using Desmos. So I have, let's see, log x plus 3. As you can see, it's steadily increasing, right? It's increasing at a very, very, very like kind of flat rate here, but it doesn't really like it doesn't have, again, it doesn't have a negative. I can't take the log of a negative number, right? And in this case, it exists in the negative domain, so log x cannot be my answer in this case. Remember, log is just simply the inverse of an exponential function here. So which means A here cannot be our answer. Let's look at B. Let me bring up the graph here so you can see B here. Let's do B. B is an exponential function. I have y equals 0.2 to the power of x plus 3. And if I sketch this graph here, again, an exponential function looks like this, right? If this was like 2 to the power of x. However, if my base here is between 0 and 1 here, I have a decreasing function, right? So I have something like this, right? I have a decreasing exponential function here. So again, I don't have, it only exists in the in this case the domain works, it's increasing this way. However, again, my y value cannot be negative, right? If I take the exponent of something, I can never get a negative value. It has a horizontal asymptote at y equals 0. So in this case, this cannot be our answer as well. And a decreasing exponential cannot be our answer here. So this here was a logarithmic. So this here, a logarithmic here. This here is a decreasing exponential. Let's look at C. C here is x cubed plus 3. If I were to graph x cubed plus 3, again, I have a polynomial function, right? Let me graph this for you in blue. X cubed plus 3, it's an odd function. And it's the leading coefficient here is 1. So I have here, it would be something like this, where this here is at 3 here, right? So this case, again, it doesn't look anything like a reciprocal function. So this here is the wrong answer as well. And finally, I have D. D here is y equals, I have 1 over x plus 2 plus 3 here. And this here looks like my reciprocal function, right? If I were to graph this function, it would look oddly, very, very much so like this, right? And to prove that, I can solve for the horizontal asymptote. In this case, it's here. I can set this value here, and I would get the y-intercept in this case would be indeed at y equals 5 here. y equals 5 here, because if I set x is 0, I get y equals 5. Or sorry, that's my horizontal asymptote, and that would have another horizontal asymptote at x equals 2. So this here, again, it's my only valid answer, right? And then what I can do is I can actually check this graph on Desmos. So let's check this graph here and say that y equals, not y equals, I have 1 over, this is x plus 2 plus 3 right here. So I have, in this case, if you look at the function here, it actually does not match this graph at all. So the reason why here is that I looked, the graph here is actually wrong. I don't know who drew this graph, but this graph here is actually wrong. But it's the only, I think it's asking for the family of the graph and not specifically like the horizontal and vertical translations as well. Because if I look at this graph here, x plus 2, my horizontal asymptote is obviously here at 0, right? I set this entire thing into 0, and my vertical asymptote here is indeed at this here would be leading to minus 5 here. So again, this here is the wrong graph in terms of like when we talk about like translations and stuff. This is the wrong graph, but in this case, it would be our correct answer simply just based off the family of the graphs. So this here, option D is the correct answer. Incorrect here since y-intercept lies between 3 and 4. So they use actually y-intercepts and not families of graphs. So in this case, it's correct answer, but they kind of used the wrong concept, but used the wrong concept to solve for the solution. So basically, the correct answer to this in terms of like the concepts, we have to talk about the family of the function, right? So A represents a logarithmic function. B represents a decreasing exponential. C represents a cubic function, polynomial. And D here represents a reciprocal function, right? Sorry, reciprocal, spelled like that. So in this case, based off graph, D is the only valid answer. However, the graph does not actually equal whatever they had here, which is 1, y equals 1 over x plus 2 plus 3. It actually does not equal that. So this here, I'll say solution is correct.